ocean has to offer on a daily basis. So thank you for coming. We're lucky enough this evening to have Dr. Lowe is going to give our presentation. I was fortunate enough to see him last year in Newport Beach, and then a couple years ago at a lifeguard symposium up in Manhattan Beach about this similar topic. He's marine biology professor at the Cal State University of Long Beach and director of the Shark Lab, which has been going, I know they've been studying great whites for the past 10 years. I don't know if the lab's been around longer than that. Since 69, excellent. But thank you guys so much for coming. For those of us that didn't hear, restrooms are out the back around to the left end of the breezeway, and then they'll be on your right-hand side over there. Please help yourself to the cookies and water. Anything in the back what you don't take and eat, we'll have to carry back to lifeguard headquarters, so save us the trip. And thank you very much for coming. Let's give a warm San Clemente welcome to Dr. Lowe.
So, a lot of people have been asking me lately, what is going on? And of course, for the last 10 years, we've been kind of trying to figure that out. And believe it or not, there's kind of a story to this whole white shark thing, that the deeper I dug, kind of the more surprised I became, and I think many of you might be too, because it's something that's been happening underneath our noses, we just haven't recognized it. So there's a story that I'm going to start with that will lead to, so don't get discouraged if I'm not talking about sharks right away. It'll come, I promise. Okay, so the bottom line is we hear about bad news every day, right? In the news, we hear about oil spills, we hear about overfishing, we hear about all the problems with the ocean, biodiversity loss, ship strikes, trash, pollution, bycatch. We hear about these things on a daily basis. So the reason for most of that is really simple. We have a growing problem on the planet, right? There are more and more people. So we have exponential growth in humans. If you look and you go back a couple millennia, you'll see that human population growth has been increasing exponentially. And of course, California is not immune to this. So California, you go back to the late 1800s, there were only about 20,000 people living in California. And of course, now there are over 38 million people living in California. And over 70% of those people live within 60 miles of the coastline somewhere in California. So as a result, all of that human population have had impacts on the coastal oceans. And those impacts have been occurring, as you can see, going back 40, 50 years now, and it's grown substantially since then. So many of you that have been long-term Californians know that California's had its hazy days, right? So we had a big problem with air pollution, and the worst problem with air pollution in California was back in the 40s, and it actually got peaked at about the 70s, but since then, things have actually gotten a lot better. I mean, it was so bad that people would talk about not going outdoors on certain days, or certainly not exercising. So the bottom line is, it was in the 40s where Californians first started to recognize our air quality problems. Concerned citizens pushed for greater science and pushed for regulation in California and in Washington. And in 1970, landmark legislation was passed in Washington, D.C., which was the Clean Air Act. And that was driven largely by Californians. So because of the air quality in Southern California, that drove a lot of that national legislation. The thing you have to remember is everything we put in the atmosphere eventually ends up in the water. So air pollution does affect the ocean. Of course, we have better air quality now with 3 to 5 times more people and 20 times more cars on the road. So we did that because we recognized a problem. We put legislation and regulations in place to deal with that, and guess what? We have cleaner air now with more people. Of course, we've had the same issues with water. So water quality was a big problem. Back up into the 70s, we were discharging pretty much raw sewage into our coastal environments. And all of that was just basically getting screened out. In addition, in Southern California, we had a lot of industry, which was also dumping into our coastal oceans. And I think the thing that most people don't realize is, remember, a high percentage of the public live within 60 miles of the coast. So in Southern California, you're talking about 22 million people. 22 million people going to the bathroom every day. That goes out 8 pipes, 8 from Santa Barbara to San Diego. So that's a lot of wastewater treatment. So in the 70s, we were literally discharging raw sewage a mile offshore. The pipes weren't very far offshore, and we had some of the worst coastal water quality that existed anywhere in the country in Southern California because of the rapidly growing human population. However, in addition, we had industry which were dumping hundreds of tons of contaminants into the ocean through the wastewater treatment system. So again, concerned citizens complained about water quality issues, complained about pollution issues, and in 1972, the Clean Water Act was passed. So the early 70s was kind of like the environmental revolution in the United States. So now we have secondary, in some cases tertiary wastewater treatment. We have the best wastewater treatment that exists anywhere in the world, handling the greatest high density of population that exists anywhere. So we have cleaner water now than we did back in the 70s with 3 to 5 times more people. That is an impressive feat, right? But that was concerned citizens that complained. Now, granted, we still have pollution problems. We have coastal runoff, we have trash problems, and we need to continue to work towards fixing those things. But my point is, we've done a lot in the last 40 or 50 years to actually improve our coastal oceans. Of course, California is a community of seafood lovers. We've been that way. California's initial economy was based on commercial fishing. It started and was founded on commercial fishing. Ports like San Francisco, San Pedro, San Diego were the major fishing ports along the entire West Coast. So when you consider how many commercial fisheries have existed, there have been some interesting changes in the last 50 years. So for example, purse seine fisheries, which were really prominent in Southern California, started in 1915, and they were targeting things like tuna, barracuda, white sea bass, wet fish, which is how we refer to sardine, anchovies, bait, largely bait. All those fisheries are gone. All those commercial fisheries have collapsed. They've either moved other places, all the ports that supported these fisheries have changed greatly, and the only commercial purse seine fisheries that exist anymore are for squid. So squid is one of the largest commercial fisheries still in California. We had trawling that occurred in Southern California and throughout California, and trawling basically is using an otter trawl. It's a net you drag along the seafloor, and you target animals that live on the seafloor. So originally they were targeting whiting, they were targeting flatfish like halibut, flounder, sole, things like that. Most of those fisheries are gone. There are about 7 or 8 trawlers left in all of Southern California that still trawl for halibut. There are only 3 locations in Southern California that they're allowed to trawl. That commercial fishery is gone. Entangle nets, which we also refer to as trammel or gill nets, these are nets that you put in the water that fish can't necessarily see. They swim in and they get caught around the gills. Unbelievably effective method of fishing. Now, it started in California back in 1940 using cotton line, but cotton line was visible, so the fish could actually see it. So it wasn't effective until the 70s with the advent of plastic. So now we went to monofilament. Now the net could become literally invisible in the water, and it was become much more effective fishing method. So it really grew in prominence in 1970s. It peaked in the 90s, and that fishery crashed in literally 10 years. So in 1994, the state of California passed the Proposition 132, which was the nearshore gill net ban. It prohibited gill netting from the coastline out to 3 miles. And a lot of the reason for that was depletion of target species. However, there was also an offshore gill net fishery that was targeting things like swordfish, tunas, and sharks. So in addition, we've had hook and line fishing. We have long lines. So long lines are basically one very long line with many hooks. Offshore, we use those to target things like swordfish and tunas. Inshore, we put them on the bottom to target things like halibut. Now, all those commercial fisheries are gone. By and large, they've left California waters. They're either fishing Hawaii or other places. However, we've replaced a lot of the commercial hooks with recreational hooks. So now it's estimated that there are at least 1 million recreational anglers that fish in Southern California. That's a pretty high number. So the bottom line is, if we look at just consumption or seafood harvest, we've had over 100 years worth of intensive pressure in California coastal waters, and that resulted, not surprisingly, in declines in a lot of species. But the species most affected by all these commercial fisheries were the predators. And predators don't just include the sharks. They include the whales and the seals, and many of those animals are also considered really important ocean predators. So by the early 1900s, most marine mammals in California waters were hunted to what was thought the verge of extinction. So we had a lot of dirty fisheries after that. So we had commercial fisheries that, even though marine mammals were protected in 1973 from being killed, there were a lot of fisheries that were incidentally catching those animals, and the federal government cracked down on those fisheries to reduce bycatch of a lot of those marine mammals. But by and large, we had a systematic loss of predators. So the thing is, you got to remember, about 2 generations of Americans have enjoyed the benefits of complete unfettered access to the marine environment without ever having to worry about the fact that they may encounter an ocean predator. So the bottom line is, we recognized all these losses 30 to 40 years ago, and legislation has been put in place both federally and through the state of California to bring some of these predators back, because we recognize their importance and their need in having them in our coastal oceans. So in 1973, Marine Mammal Protection Act was passed to try to bring marine mammals back. In 1994, we passed the nearshore gillnet ban to try to restore populations that were rapidly overfished in that fishery. In 1996, the Magnuson-Stevens Act, which is the federal act that requires the federal government to adequately manage fisheries in federal waters. That's from 3 miles out to 200 miles. And then, of course, Californians are very ecologically conscious, passed the Marine Life Protection Act in 1999, which has started many of the marine protected areas and things like that. So we have recognized many of the problems that I'm mentioning decades ago. But what I would argue is we're seeing the benefits of these things now. And it's taken decades to happen, but I'd argue that we're starting to see those. And that's where we start talking about sharks. So the bottom line is, all of these things, water quality, air quality, overfishing, the species that are most vulnerable are the ones at the top of the food chain. So the predators, the carnivores at the very top of the food chain occur in fewer numbers, and of course they're dependent on everything else lower in the food chain as their food source. So if these are the ones most greatly affected by pollution, by overfishing, obviously it's going to have effects on lower parts of the food chain. So probably for 50 years, we have had a coastal food web that has been dramatically out of whack. So predators, of course, are kind of like the canaries in the coal mine. They tell us a lot about how the rest of the ecosystem's doing if they're coming back. If they're not coming back, that tells us we still have a problem. So what does this have to do with sharks? Well, I want to talk about gillnet fishery. Now, the gillnet fishery was an important economic fishery for California. It brought a lot of money to California. It fed a lot of people, but it was also a largely uncontrolled fishery for many years. So there were 2 fisheries. There was one that set gillnets offshore that were targeting swordfish, tuna, and sharks. And there was another one set inshore that was targeting things like white sea bass and California halibut. So these 2 fisheries grew very, very quickly, as I pointed out, and they literally went from overnight, because you could fish a gillnet out of a small boat, 30-foot boat. You could go out and set nets. And fishermen were making good money when that fishery first started really fast. However, they rapidly reduced the number of halibut and white sea bass. In fact, I would argue that that fishery was largely responsible for the declines that we saw in white sea bass in the state of California. But what really did the damage to that fishery wasn't so much the declining in target catch, it was the bycatch they were getting. They were killing turtles, they were killing lots of sea lions, they were killing seabirds, and a lot of other species, including sharks, that weren't being marketed. So this fishery was enough, the problems of these things were enough that it was brought to the voters of California in that Prop 132. I mean, think about it. How often do you hear about fishery regulations being brought to the voters? It just doesn't happen. But this was a serious enough problem that it warranted that. So the interesting thing is, if we look at this fishery, so the blue is the nearshore gillnet fishery, the yellow is the offshore gillnet fishery, and what you see is the number of nets being set peaked in the mid-'80s, and then it steadily declined, and the fishery was heavily regulated in the mid-'90s. So at its peak, there were over 1,000 permits issued. There were over 1,000 boats fishing gillnets in California at its peak in 1985. And in a period of 7 to 8 years, that fishery crashed. It literally crashed. So the gillnet ban goes in place in 1994. The offshore gillnet fishery gets heavily regulated in the mid-'90s. But since then, gillnet fishing still exists in California. But since then, the number of gillnets being set has remained stable. So This is a really important part of the story because gill netters are still out there fishing. They're still providing us with fresh fish. But I would argue they're doing a lot less ecological damage than they did before. Now there are only 140 permits still in existence, but only 40 boats using them. So there's only 40 boats still fishing nearshore gill nets. And there are only 16 vessels, actually this year, there's only 12 vessels left in the offshore drift gill net fishery, and that fishery will probably be extinct by the end of this year. So there's been an 82% reduction since its peak. Okay, so if we look at where the fishery is fishing in Southern California, all these blocks are called Department of Fish and Game fishing blocks. So when a fisherman catches a fish and they have to report their catch, all they have to say is what block they were fishing in. So they're 10 nautical miles by 10 nautical miles. And it helps protect the fisherman's secret fishing spot when they report. So what you can see is a bulk of the fishing prior to 1994 was occurring throughout the entire Southern California bight. That's from Santa Barbara all the way down to the Mexican border and all the way offshore 100 plus miles. But you can see a majority of the fishing was occurring in coastal areas. Off Huntington Beach, San Pedro, off San Diego, off Ventura. That's where a bulk of the fishery was. Remember, mid-90s, fishery was heavily regulated. This is going to fade out. Now you're going to see after the gill net ban, you see that gill net effort is significantly going down, but the remaining gill net fishery is still fishing in these same areas. It's fishing off Huntington Beach. It's fishing off Ventura. And those are the major ports where most of these gill netters fish out of. So there's still gill net fishing occurring in Southern California. Now, here's the important part. So here's a target species. This is white sea bass that the fishery is targeting. Back in the 60s was the peak in catch. It bottomed out in the 80s at the beginning of that gill net fishery. It was literally gone by then. And it has remained virtually gone until after 1994, the gill net ban goes into place. And since then, gill net landings of white sea bass have been steadily rising, and they continue to rise. Recreational fishers are catching more and more white sea bass. So this one regulation of banning nearshore gill nets has allowed this fishery to come back. There are gill net fishermen making a living catching white sea bass, and the population continues to rise. In addition, there were a lot of other species that were caught as bycatch in that fishery. These included giant black sea bass, these included soupfin sharks, and leopard sharks. And since the banning of nearshore gill nets, all of these populations have been steadily rising. So as a fisheries biologist, that tells me that that regulation did a lot to bring back many of the coastal populations that were directly affected by that fishery. Okay, but here's really a really interesting one. So remember, all our marine mammals have shown resounding capacity to recover. But I use California sea lion as one of the best examples. So these are the numbers, estimated numbers of California sea lions. By 1920, it was estimated that there were only 2,000 California sea lions left in all of California and Baja, which means by 1920, if a fisherman saw a sea lion, they simply shot him. It's perfectly legal. They viewed them as competitors, and every fisherman that would go out of the harbor, if they saw them in the buoys, pull out their gun, shoot them. So by 1920, marine mammal biologists thought California sea lion was gone. They were on their way to extinction. What happens in 1973? Marine Mammal Protection Act comes into place, and look what the population starts to do. It starts to go up. But we see this dip. Anybody know what happened in the early 80s? El Nino. We had a really strong El Nino, and boy, did that put a hurting on the sea lion population. So guess what this last El Nino is doing? After we bounce out of that, in the mid-90s, what happened? We put in all those fishery regulations in place to protect these animals, and since then, the population has been estimated to grow at a rate of 6.5% per year. Marine mammal biologists thought that was impossible. Gray whales were growing at a rate of 10% per year. So in the 1990s, remember the news? You guys hear about it all the time. Our coastal oceans are overfished. They're completely polluted. Everything is gone. This is one of the biggest carnivores in our coastal waters. But their populations are growing at a rate of 6.5% per year. How can they do that if there is no food for them? So the bottom line is these populations are growing at that rate because there is food for them. Now, in 2012, NOAA concluded that the California sea lion population has reached its carrying capacity at somewhere between 220 and 470,000 animals. So in less than 100 years, this population went from being on the verge of extinction to potentially there being more California sea lions on the planet now than there ever was. Now, what does this have to do with sharks, particularly white sharks? What do white sharks like to eat? Marine mammals. And the marine mammals have done really, really well. Okay, so shark populations worldwide have taken a pounding. And just for the same reasons that everything else has. They were worth money, so they were overfished. They grow differently than any other fish. They grow more like humans, so they're very easy to overfish. And of course, those fisheries were occurring before we really knew anything about their biology. In addition, they're slow growing. They take a long time to mature. Some sharks don't even reach sexual maturity until they're 22 years old. They may only produce one young every 3 years. They may live to be 70 years old. All of these characteristics hopefully sound familiar, right? Because that's like us. So obviously, when you overfish these populations, it can take decades for them to recover once they're protected. In addition, what made it easier to overfish them was their reputation, right? So it was things like Jaws, it was shark attacks, it was those sorts of things that actually fueled the overfishing. Because people were saying, yeah, I don't care if the fishermen kill all the sharks, that's a good thing. I feel like I can go in the water safely. Well, actually, you may think that, but it doesn't necessarily change your likelihood of being bitten. And, of course, it has bad effects on the marine ecosystem. That's why there are 470,000 California sea lions jumping and sinking people's boats now. So the bottom line is white sharks, we've recognized, based on our historic knowledge, have life history characteristics very similar to us. Males reach sexual maturity around 7 to 8 years old. Females reach sexual maturity around 12 years old. But they are of value. While there's never been a directed fishery for white sharks, when they have been caught, either accidentally or occasionally targeted, they're worth money. Jaws, for example, a set of adult white shark jaws can sell for over $16,000. And the fins from a single white shark are worth over $200 a pound. So by the time you take those fins off, you dry those fins, you're looking at probably 40 pounds worth of fins. Do the math. And of course, their meat is perfectly edible. They're closely related to thresher sharks and mako sharks. So in fact, there's great examples of white shark being marketed in California prior to the gill net ban. So although they don't occur in high enough numbers to actually target them, they've always been of value. So when anybody caught them, they landed them. So what surprised me the most, in 1994, the same year they passed the nearshore gill net ban, the state of California passed legislation to protect white sharks in state waters. And that's kind of shocking, because white sharks have a reputation for occasionally nibbling on people, right? So you would wonder why the state would do that. But the bottom line is we recognize, because of many of these things we've learned, that they're very easy to overfish. And we recognize their importance in the ecosystem. So in 1994, they were protected in the state of California. They were protected in the U.S. Atlantic and the Gulf of Mexico in 1997. They were protected under CITES. So in other words, their jaws, their teeth, their fins could not be traded among countries in 2004. And in 2005, they were protected throughout the rest of U.S. waters. So for 10 to 20 years now, white sharks have been protected in U.S. They've been protected for 20 years in South Africa, Australia, Mexico, and New Zealand. So in all these places, white sharks have been protected. Well, if you put protection in place, what should you expect to happen? It should work, right? So guess what's been happening? It's been working. So what do we know about white sharks? Well, one of the things we've learned, in fact, 20 years ago, if you asked any shark biologist what kind of shark we thought a white shark was, we would have said a coastal shark. And if you said, well, how do you know that? We'd say, okay, in the fall months, we see adult white sharks along the central California coast, off the Farallon Islands, off Año Nuevo. They'll come in right close to shore. And the reason is they're coming in to take advantage of elephant seals that haul out on the beach and give birth to their young. Now, an elephant seal is like a fat burrito for a white shark. Easy to catch, can't swim very fast, super fatty. So it's the best meal a white shark can get. So these sharks were being sighted along these areas. In addition, about 15 years ago, researchers and fishermen began to realize that there are a lot of white sharks around Guadalupe Island off the coast of Baja. So these are two what we call feeding aggregation sites where adults congregate in the fall to take advantage of elephant seals and seals that haul out during that time. Now, remember I told you we thought they were a coastal shark? Technology. So my colleagues from Stanford and Davis and Mexico universities began to tag sharks using satellite tags, where they mount tags to the sharks. And what we found was these sharks would actually only spend a month or two around those islands and then spend the rest of their time out in the middle of the Pacific, between California and Hawaii. Some of those white sharks would actually go to Hawaii, and they would spend anywhere from 8 months to a year and a half out there before returning to one of their aggregation sites of either Central California or Guadalupe. So literally in a period of 5 years, we went from considering a white shark a coastal shark to considering a white shark an oceanic shark. Why? Because they spend a bulk of their life out in the middle of the Pacific. We have no clue what they're doing out there. We just know that they're smart enough to come back to coastal waters to take advantage of easy, fat seal burritos, right? Okay, the other thing that we've learned is that our front yard, the Southern California Bight, from Santa Barbara down to mid-Baja, is a nursery for white sharks. And we've actually known this for quite a while because we actually found fishing records going back to the late 1800s of recreational fishermen catching baby white sharks in Santa Monica Bay right off the beach. So based on the size of these small sharks, we know that these are newborns. So a newborn white shark is about 5.5 feet long at birth. A female can give birth from anywhere from 2 up to 14 5.5-foot long babies in a single birthing. So this whole area has historically been known as a nursery. Now, it's not just a nursery for white sharks. It's a nursery for mako sharks, thresher sharks, salmon sharks, blue sharks. So the Southern California Bight, our front yard out offshore, is considered one of the most important nurseries for sharks in the entire Pacific. Our front yard. So one of the things we were curious about was to what degree do white sharks interact with fisheries? So to do this, my students and I combed through every fishery record we could find, dating back as far as we could find, and we found from 1936 to 2009, 369 records of white sharks being caught in any fishery in Southern California. So when we started looking at those records in more detail, we found some really interesting trends. So a yoi is what we call a baby white shark. It's a young of the year. It's less than 1 year old. So these sharks are less than 6 feet long, and a bulk of what was reported caught in any fishery in Southern California were these babies, right? So they're about the size of a leopard shark, maybe a little bit bigger than a leopard shark. Those sorts of size classes were the ones most commonly caught. Juveniles are between 6 and about 11.5 feet long, and then anything typically over 12 feet long is considered an adult. So not surprisingly, not a lot of adult white sharks were caught in any fisheries, mainly because very few California fishery gear can actually stop them. Gill netters tell me about pulling up their nets and finding holes in the net that you could drive a Volkswagen through. And when they tell me about that, I go, yeah, I think I know what did that. So the bottom line is, we know they're around, they just weren't being caught in many of these fisheries. Now, when we looked at the different fisheries, so blue is babies, red are juveniles, yellow is subadults, and green is unknown. When we look at the different fishery types, this was really telling. This comes back to why I was telling you about the gill net story. Over 80% of the sharks reported caught in any fishery were caught in the gill net fishery. And a vast majority of those were the babies because that was the right size net that could actually keep them. Bigger sharks could actually get through the nets. Set line, harpoon, many of these caught a few sharks. One shark was found caught in a lobster trap. He got his head stuck in a lobster trap. Fishermen pulled it up. And of course, recreational fishermen have been catching more and more of these white sharks as well. But it was by and large the gill net fishery that had the greatest impact on white sharks. So when we look at where all this fishing occurred by location, if we look at adults, we see, and again, this is really important because people have been asking these questions a lot about adult white sharks. There are very few places along the Southern California coast where we actually see adult white sharks. And if you look at fishing records, that's backed up. So Palos Verdes, off Catalina, off Anacapa, were the few places where adult white sharks were reported caught. When we look at juveniles, now we see more coastal activity. We see more being caught in certain locations on the coast, in the Santa Barbara Channel, off Ventura, off Santa Monica Bay, off Huntington Beach, off Dana Point, San Clemente, and off San Diego. But it's when we get to the babies that you really see this pattern. So it's really Ventura, Huntington Beach, a little bit off Dana Point, and San Diego. Now these are all primarily coastal areas that these sharks are being reported caught. So can we use that information to give us some information about where these sharks are spending their time? Okay, so this is that same gill net fishery. Remember, these are the number of nets being set. It peaked in the 80s. These are the number of white sharks reported caught in those fisheries during those years. So what we see is the number of sharks being reported caught back in 1985 peaks, and then they start to decline. So based on this, we know that the gill net fishery was probably having a negative impact on the white shark population. They were killing a lot of baby white sharks. And prior to 1994, if they had a white shark in their net, they landed them. So if you bought shark in the fish market between 1980 and 1990, there's a good chance you ate white shark and you didn't even know it because it was marketed as mako or thresher. It looks identical. After 1994, white sharks are protected. The gill net fishery is heavily regulated, so gill net fishing effort isn't changing, but look at the number of sharks reported caught in the fishery after that. So what does that mean? So remember, 82% reduction in gill net effort. Fewer fishermen fishing, but the number of white sharks they're catching is going up and up. To us, that is a sign of population increase. If there are more babies, there has to be more mommies. So this is the first good evidence that we have of population increase that isn't just stand-up paddleboarders saying, stand-up paddleboarders can see sharks, that's why we're seeing more, because they can see them better. It's not just that. There are other records that tell us that the population is probably increasing. So for the last 10 years, we've been working and collaborating with many of the commercial fishermen. So if a commercial gill netter caught a white shark, they would call us up. So this research was funded by Monterey Bay Aquarium. We had a number of these gill netters that were our partners in this research, and if they caught a white shark in their nets, they would put that shark in one of their fish holds, call us up, my students and I would meet them down the dock, and then basically we could take measurements from the sharks, we could take a tissue sample so we could do genetic analysis, we could take really good measurements, we could take a blood sample, and then we could use a variety of tags that we could put on the sharks to answer questions about, number one, if it's caught in a gill net, can it survive that? And number two, where do they go? So then here's a juvenile white shark in a fish tote. It's only about 4 feet by 4 feet. Those are legal-sized California halibut, so that kind of gives you an idea of how big they are. And then the fishermen would drive us offshore and release the sharks. So to answer questions about, number one, can they survive being caught in a gill net, we used several types of technology. So one type are called satellite tags, and Ryan will pass around or show some of this technology that we're using. So one type of tag we use are called spot tags. These are tags that actually get bolted to the shark's dorsal fin. And because satellite transmitters are radio transmitters, the only time they can transmit is when the antenna is in the air. So every time the shark comes to the surface and it breaks the surface, this radio transmitter will start transmitting to a satellite, and then I get an email alert at my office saying, shark number 205 just popped up, and it'll give me a longitude and latitude. But you have to remember, sharks are not marine mammals. They do not have to come to the surface to breathe. So we did not expect to get a lot of information from this, and I was shocked at how much we did get. But they only work when the shark's at the surface. The other types of transmitters we use are called PAT tags, pop-off archiving satellite tags. Now these have data loggers in them that are recording temperature, light, and depth every 10 seconds. And they'll log that data for as long as they can, and these get darted into the shark's back. Think of it like an earring, right? Shark carries this with it, and we can program this tag at a particular date and time to pop off the shark, float to the surface, and download all the data. Now we know the depth that the shark's been at, the temperature of the water that it's moved through, and we get some rough estimate of its position based on light and time. So like the old sailors used to navigate using, midday, and if you knew the length of the day, you could get a latitude and longitude. Using this technology, we can get a guesstimate of the shark's position at about 60 nautical miles. So not super accurate, but it was enough to show us how far sharks may migrate. And then the other technology we use, because frankly, sharks spend most of their time underwater. And if we want to know where they are in close proximity, we use something called acoustic transmitters. Now, these transmitters produce an ultrasonic ping. Each one has a unique ID code. We can either dart those into the shark's back, or we can surgically implant them into the shark's body cavity. And then we have these listening stations all along the coast that are constantly listening for sharks 24/7. So if a shark swims within about 300 yards of one of these receivers, it logs the ID number, the time and the date the shark came by. So think of this like Easy Pass on the toll road. You know how you drive down the road, and at the end of the month you get the bill? Sharks don't get the bill, we get the bill. But nonetheless, we can use this to kind of log how close they are to shore and where they're spending their time along the shoreline. So since 2006, we have put out probably close to $600,000 worth of technology to answer some of these questions. So here's a map showing the Southern California Bight. The cell colors that you see, the redder the color, the greater the amount of gillnet fishing that occurred in that area. Now remember, this line you see right here is the state demarcation line. So even though there's color inside here, gill netting is illegal. So all these symbols you see are locations of where commercial gill netters had caught juvenile white sharks. Now when you look at that, you go, ooh, that's not good. Because all this red area, look at all the sharks that are caught there. That's bad. This fishery is interacting a lot with those sharks. But remember, that's an artifact. We know they're there because they caught there, right? But if we use the spot tag, every time they pop up and we get a really nice, accurate location, if we use those data to ask where the sharks, when they're not being caught by fishermen, we see, oh, and by the way, this is really interesting. So a majority of the sharks that we caught were from Ventura fishermen, Santa Barbara fishermen. Look how many were caught and released in Santa Monica Bay. Now watch this. These are locations where they were detected by the satellite. All the white dots you see are detections inside 3 miles where it is illegal to gillnet fish. Think of that as a protected area, right? All the black dots you see are areas where gill netting can occur. One of the things you'll notice is that sharks aren't spending all their time in the places where the fishermen are fishing the most. And what I also found really interesting is that even though a bulk of the sharks were caught and tagged in Ventura, look at how much time they spend in Santa Monica Bay, which is largely protected. So using this technology, we're able to answer questions about the impact that the gillnet fishery is really having on white shark populations. So number one, we wouldn't get any of those dots if every shark caught in a gill net that was released died. We wouldn't get any dots. So the fact that we're getting dots is telling us that sharks caught in nets can survive. The other thing it's telling us is that these sharks are moving all over, but there are hot spots along our coast. And those hot spots are the same ones that the fishing records showed. Off Ventura, off Santa Monica Bay, off Huntington Beach, and off Dana Point. So these hot spots are corresponding to fishing records as well. Okay, now, one of the other interesting things we found during this project was that some years there would be a lot of sharks caught that were found dead in the nets, and other years, very few. So, we started asking the fishermen, what's going on? Why some years a lot of dead sharks and other years not? So one of the things that we found was that if a shark was found live in the net and they brought it back to the dock so we could do all those things to it and let it go, 94% of those sharks survived. So when we started digging in a little deeper and asking the fishermen about how they were fishing, one of the things we found was if they checked their nets in under 24 hours, there was a much higher likelihood that the shark would be alive. However, if they only checked their nets in 40 hours, there was a higher likelihood of a shark being dead. So if we have a mortality problem from the fishery, we gave the fishermen a great database solution. Check your nets more often, and you'll have fewer dead white sharks. You get to keep fishing. We know the sharks will survive. Okay, so the satellite telemetry told us that a lot of these sharks could be detected in close to shore, but remember, we only get those detections when they're at the surface. One of the things that we're simultaneously finding was people were seeing a lot of sharks very close to the beach, very close to the beach, just outside the wave break. And a lot of this were being spotted by stand-up paddle boarders. There were people flying drones, pilots, all sorts of folks were telling us they were seeing more and more sharks just outside the wave break. So one of our questions was why? Why do these little sharks do this? So here's an aerial photograph. PCH is literally just off screen. This is Will Rogers Beach. Here are 2 stand-up paddle boarders. How many white sharks do you see? 5. That's kelp. That big green thing is kelp. But in an area the size of a football field, here are 5 white sharks. Off Santa Monica last 2 years ago, we had 14 white sharks sighted between Redondo and Manhattan Beach Pier. Last year off Huntington Beach, Sunset Beach, they counted 13 from, I think it was Edinger to Anaheim Bay. So, I mean, we know that these little sharks can occur in relatively high numbers in areas where there's a lot of beach activity. So in order to get more information about these sharks, we need to be able to capture them. And one of the challenges is, unlike commercial fishermen that may be fishing every day, we're trying to do this on our own. So one technique we use is if the sharks are far enough off the beach, we would hire a commercial purse seiner. We'd have a professional pilot spot, and then the purse seiner would literally set the net around the shark. We could purse up the net, purse up the net, purse it up, and eventually we could literally get the shark into a sling, bring it on the boat, and do all the things that we would do that we would do if we got a shark from a gill net fisherman. The problem was our scientific collecting permit would not allow us to fish within 900 feet of the beach. A bulk of the sharks are literally 200 feet off the beach, so we had to come up with another technique. Now my grad students like Ryan love this technique. So this technique, we work closely with the lifeguards at Huntington Beach. Lifeguards have their jet skis, they have their tow boards, and what we do is we put one of my grad students on the back of the tow board with a pole spear, and the pilot or a drone pilot would be telling them where the shark was. And what they would do is drive up in front of the shark, and as the shark would swim by, they would swim next to it and jab a dart tag into the shark's back. So here's one of the tags, like a little earring, just gets jabbed into the back. This tag will last about 2 years, probably stay in. After that, they fall out. But this gave us an opportunity. In fact, last summer we tagged 16 juvenile white sharks off Huntington Beach. It's the most sharks we've ever been able to tag using this technique. So here's some data I'm going to show you. These dots are locations of receivers. And by the way, Ryan, this is my grad student, Ryan. He's doing another research project where we have 42 acoustic receivers off Wheeler North, the artificial reef out here, and literally right off your pier. So each one of these dots represents a location of a receiver. And there's going to be a time date counter up here. And what's going to happen is every time we get a detection, one of these red dots is going to flash. Oop. Okay, so what's the time date counter? So we had 3 sharks tagged up in Ventura. So you can see by time of day, we're getting lots of detections very close to shore. San Clemente was very popular last summer, back in 2015. And then you're going to see animals start hopping around. So many of these are babies. And by the way, we're going to have a new website coming out that you'll be able to access these data and play with these data and check them out, learn more about the project. So in any event, this gives us the ability, and you can see during the summer, all the sharks that we had tagged were being detected in all the hotspots simultaneously. Surfside, Sunset Beach, that was very popular last summer. We had a lot of activity that animals would move from here down to San Clemente. We had animals moving from Santa Monica down to San Clemente. So one of the things we had learned probably about 5 years ago, and we thought we had everything figured out, based on the SATA, the pop-up, the PAT tags that we put on the shark's dorsal fins, the spot tags, sharks would spend their whole first summer kind of moving back and forth along our beaches. And then in October, November, when our water temperatures started to drop in November, they started moving further south. And by late November, when our water temperatures get below 58 degrees, they would haul tail down to Baja. Every single shark we tagged during the summer did that. Some of them went all the way down, around, and inside the Gulf. And a small proportion of those that overwintered came back to Southern California the subsequent summer. This was prior to El Nino. In 2014, we only tagged 1 or 2 sharks that summer. Those sharks stayed around all summer, but we didn't have winter in 2014. Water temperature never got below 62 degrees. Those sharks never left. They stayed. In 2015, we tagged more sharks. That winter, again, we didn't have winter. None of the sharks left. None of them migrated. So people have been asking me, what's going on? The shark population has exploded. I'm like, no, it hasn't exploded. The behavior of these sharks have changed because of El Nino. And as a result, there's more sharks around because normally they would migrate out in the winter. And some of them that migrate to Baja stay in Baja and don't necessarily come back to Southern California, or they get caught in Mexican fisheries. So the thing that we've been seeing the last 3 years is a combination of the white shark population going up, but also the effects of El Nino. And it's not just white sharks that have changed their behavior. Many of our other coastal species have changed their behavior as a result. So we are in the process of developing new technology to begin to better answer some of the questions. So one of the tools that we're developing is we're developing autonomous underwater robots that will track a tagged shark. So the cool thing about these robots is we can program them, we can put a transmitter on a shark, and we can tell the robot, never get within 100 yards of that shark. But the robot, using these 2 ears, knows exact location of the shark while it's tracking it. We can program the robot to move up and down through the water column, so it's measuring water temperature, it's measuring chlorophyll, tells us something about productivity. It has a video camera, so it's recording everything it sees, and we can have image sonar, so even at night, we get a video image based on sound of schools of fish, other sharks. So this technology is going to enable us to kind of patrol on the beaches, the sharks that we have tagged. We can program this to move back and forth along the beach, because one of the things we're seeing in not just Santa Monica and other locations is that there are literally half-kilometer stretch of beach where these sharks will spend all their time. So why not go a half-kilometer that way? Why don't they do that? They just don't do that. They use a particular stretch of beach, and they'll use it consistently. By using this technology, we're going to be able to begin to answer those questions that we couldn't answer any other way. The other tools we're using, these are called smart tags. So we'll show you what a smart tag. So here's a leopard shark we tested it on. So this has a 3D accelerometer. So it's measuring acceleration in 3 dimensions like your phone does, or a Wiimote, right? And it's measuring it 30 times a second. So we get every single lateral up-down movement the shark makes. It's got a depth sensor, a temperature sensor. In addition, it's got a video camera, so we can actually see what the shark is seeing. So this clamps on the shark's dorsal fin like a backpack. The robot can track this. It's gathering all that data, and after 1 to 4 days, this thing pops out, floats to the surface. We go pick it up, and we can download all those data. So what you're seeing here is the actual tail beat frequency, how fast the tail is beating, of a leopard shark just kind of casually swimming around. So by coupling all this technology, we can begin to ask questions like, why did that white shark that was using this stretch of the beach suddenly move to the surface? Or why did it go to the bottom? Was it hunting stingrays? Or were there too many people and the shark moved down here? So by coupling all this technology, we'll be able to answer questions we've never been able to answer before. We're using drone technology. The lifeguards are using this, and rightfully they should, because it's an unbelievable, valuable technology. So the technology we're developing actually is taking existing aerial vehicles, aerial drones, but what we're doing is we're developing parallel cameras. So you have 2 parallel video cameras that basically will take and synchronize 2 frames, and because we know the distance between the 2 cameras, regardless of how high the drone is or how deep the shark may be in the water, we can use this as a way of measuring the shark. This always becomes a challenge for lifeguards, right? Because they have classifications as to whether the shark is over a certain size, whether they should pull people out of the water. So this will provide them with a good real-time tool to decide exactly how big that shark may be. And in addition, we might be able to even do some species identification based on the outline. So a lot of software already exists. We're just taking existing software, modifying with the technology to provide lifeguards with the tools they'll need to be able to answer these questions. And of course, it's a valuable science tool for us as well. The other tool that we've been using are what we call RUVs, Remote Underwater Video Systems, basically GoPros on a stick. So what we do is we take a PVC pipe, we put a dumbbell weight there, we have a T-bar, and we have one GoPro pointing in one direction and one pointing the other. My grad students swim these out just outside the wave break, and they stick them in the sand. And they turn the cameras on, they let them run for 2 hours. So they're literally just outside the wave break. And of course, the sharks are curious by this. And here's Here's some footage. So that's a baby white shark swimming up to the camera, and sometimes they'll rub on the cameras. So the cool thing about this is because they get so close, we can actually identify individuals based on their unique marks. So I have undergrads in the lab who go through the video footage, and they will make drawings identifying where these unique markings are. And if we can get that from both sides of the shark, we can actually begin to identify individuals. So there are some sharks, obviously, will never be able to catch and tag or be able to sneak up to dart to tag in. But by coupling all these things together, we can know how many juvenile white sharks are at this beach. So these are programs that we're trying to expand. We're trying to increase the number of systems that we have out. It's labor intensive right now. We'd love to be able to put these at more beaches. Our acoustic receivers right now, the ones that we put out, they're fully autonomous. They require a diver to go out and pick it up to download them. But the company now produces a system where we can radio link these. So we can get real-time information. So there's a radio receiver at the surface, and when it detects an animal, it sends a radio signal back, and we can link that to the web, send out email alerts, that sort of thing. But what we want to do is use this as an education tool, not an early warning tool. It's not that. Remember, we cannot tag every white shark out there. So just because you don't hear any alerts doesn't mean there aren't any sharks around. So as an education tool, though, it's very valuable. So the bottom line is, hopefully I've convinced you with my story today, that shark populations are going up. That's not a bad thing. That's something we intended on when we put all that protection in place. We've had pretty much unfettered access to the ocean, and we have basically a largely uneducated populace in terms of how to interact with marine predators or even land predators. So we have a lot of educating to do. Our job at Cal State Long Beach Shark Lab is to get the behavioral information that we can then give to the public and to water safety officials so that they can give you better information on how you can be safe when you go in the ocean. So the bottom line is, we're not going to go backwards. Western Australia is culling sharks. It's not going to work. It's not going to help. And the bottom line is not making anybody any safer. So we have to learn to share the waves again. So the good news is, I think the good news is, while it's taken decades, animals that we thought were on the verge of extinction are coming back. And it's not just protecting those animals, it's been improving water quality, air quality, all the other things that we've done to clean up our environment. And the return of the predators tells us that the ocean, believe it or not, is getting healthier. So we still have problems. We have things like global climate change, which is going to have effects. Those are global effects. We've done a good job at dealing with regional ones, but we have global ones we're going to have to start to wrestle with. So I would argue that the recovery of the white shark population is probably one of California's greatest conservation success stories. So we talk about the condors. Condors are cool, very cool birds. But recovery of this animal is very impressive. So while predator recovery is good, there will be consequences. And we're going to see an increase in the number of bites on people. That's inevitable. And it's not just the shark population coming back. More people are using the ocean than ever before. And they're using it in more risky ways than ever before. So we have a lot of educating to do so that when people use the ocean for whatever reason, they can do so with full knowledge of what's out there, how they may behave, and how they can modify their behavior to be safer. Thank you. So before I answer any questions, I just want to, Ryan can kind of walk some of these things around. So these are the transmitters that we use in the sharks. Some of the ones that we surgically implant, those last 10 years. So we can track individuals almost up to the time they become sexually mature. The bad news is these are $400 a piece. These pop-off satellite tags are $5,000 a piece. These are $2,500 a piece. Acoustic receivers are $2,000 a piece. We have 100 of these. The smart tags that we've built are $7,000 a piece. And then we have these new smart tags that are commercially built, and these are $5,000 a piece. The exciting thing for me is all the technology we need to answer the questions that many of you have exists. The most frustrating part, nobody wants to pay for it. So I spend all my time writing grants to get money to do this. And believe it or not, it's really, really hard to get funding to do this work. We've had some great community partners, people just donating money or time to help with many of these things. But it's exciting to know that we can answer these questions because we've been limited by tools in the past. Now, with drones and robots and all these things, we're going to be able to do things faster than we've been in the past. So now I'm happy to answer any questions.
So how?
Oh, I'm sorry.
Have you guys gotten any closer to actually witnessing live a white shark give birth?
No, that's the holy grail for me. Being able to be there in the maternity room when that happens would be something. So the bottom line is, and that's still a mystery, we don't know where birthing occurs. We know it has to be somewhere close here because the literally newborns are on our beaches. But what amazes me today is when you consider how many people are in Southern California and you consider how many planes and helicopters are flying overhead, if these adult female white sharks, we're talking sharks that are 14, 15, 16, 18 feet long, were coming into our beaches to give birth, somebody would see it. So they're either giving birth around the offshore islands where we see them most frequently, or they're giving birth deep and then the babies swim into shore and the adults never come close to shore. So unfortunately, we just don't know the answer.
So what's your answer to behavior modification? How do you modify your behavior based on your dings, or
So,
what does that look like to you?
well, and that's a
To
tough one.
us?
Absolutely. So that's a tough one to answer, right? So the simple answer to that is, number one, regardless of everything you heard, we don't really know why sharks bite people. Provoked attacks, they're easy, right? Fisherman catches a shark, it's struggling to get away, the fisherman gets bitten, that's easy to explain. A person pulling a shark's tail to see if it's alive or to get a picture of it, them getting bitten, that's easy to explain. Unprovoked attacks, we have no idea really why they do it. It's either potentially predation, it could be defense, we don't know. So it's difficult to give people information on what they can do to change their behavior if we don't fully understand that. Now, what I can tell you is based on statistics. Your chances of being bitten while you're in a large group are relatively low compared to being by yourself. Now, most people go, you know, my quiet time in the ocean is when I get 200 yards offshore and I get to swim 2 miles. And you know what? I love doing that too. But the reality of it is your chances are worse than if you were to swim in a group of 3 or 4 people. Those are just statistics. Now, to put all of that in perspective, your chances of being out for your morning swim 200 yards offshore by yourself, if you do it every single day in California your entire life, your chances of being bitten by a shark are like winning Powerball. So if you put all this in perspective, I would keep swimming. But the bottom line is, if you're worried about it, stay in a group. Surf in a group, swim in a group, stay in groups.
You've seen any ill effects of Fukushima on marine life here? We've seen sharks with 2 fins or 50 feet long.
Good question. So one of my colleagues at Long Beach State is actually measuring radiation using kelp. So kelp are really cool radiometers. And we were able to measure radiation a month after Fukushima. But since then, we've measured 0. It's unmeasurable in the kelp. So while it has probably had certain physiological impacts on animals that live closer to Japan, we haven't seen any indication of that here. In fact, the levels are largely unmeasurable. You can't measure it. So low.
You mentioned that the juveniles eat stingrays. Is that round rays, bat rays? What is a stingray?
Yeah, so the question about what they eat, I think, fits into why they hang out where they do. So everybody keeps asking, why do those darn things have to come in close to the break? That's where everybody is. That's where everybody's surfing and things like that. And that had us scratching our heads for a while, right? So some of the sharks you caught by fishermen, we actually got to dissect. And when we looked in the stomachs, the most common thing we found were round stingrays. We found bat rays. We found a few halibut, mainly animals associated with the bottom. Okay, so when we look at why a baby white shark would come in close to the beach, my first explanation is this. When females give birth, the babies are on their own. They have to learn to do everything on their own. They have to learn to hunt on their own. And of course, I always joke, a white shark doesn't even know it's a white shark until it's over 10 feet, right? They're like baby Hueys out there. They're afraid of everything. Those small white sharks are literally afraid of everything because they don't know what a threat is. There's an instinct that tells them anything their size or larger can be a threat. Where's the safest place to be? In close to shore. There are fewer predators there. So I think one of the reasons why most of these babies hang so close to the wave break is it's a safe place to be. Second thing, there are tons of stingrays. Southern California stingray population probably in the last 100 years has skyrocketed. Anybody want to guess why? We killed all the predators. All the things that ate stingrays we got rid of. Seals, sea lions, sharks, and now they're coming back. Hopefully our stingray population is going to kind of go back again. So those are easy to capture prey. It doesn't take a lot of learning for them, and they're readily abundant. Seafloor is covered with them, so it's an easy food source. The third thing is it's warm. Water right at the beach is warmer than if you move further offshore. So those three things are the three things that I think why the babies like hanging out where we like to surf.
You mentioned increased safety, and swimming in numbers. What other safety ideas do you have?
So, there's, again, these are only based on statistics because we don't still know enough about behavior to really answer specific questions, but statistically we know that most of the bites that happen on people happen in the evening. So that late afternoon time period. The problem is we don't know if actually that's when sharks feed more. In fact, there's no scientific evidence that sharks feed more at dawn and dusk than any other time of day. And it could be a statistical artifact of, in fact, when you look at the group that's bitten the most, it's usually surfers and swimmers. And when are they in the water the most? They're in the water early in the morning and late in the afternoon, before school and after work. So we can't separate out what is shark behavior from human behavior. So the bottom line is swim at midday, swim in a group.
You had mentioned that some of the lifeguards are starting to use or have used drones. Is that something that are they routinely using that to scan for sharks in both the city and the state programs, or is that part of their normal everyday protocol, or is it just sort of some stations or as they like or how?
Yeah, I think there would be a lot more lifeguard stations that would like to adopt them. They're expensive, right? And you, of course, have to have some training so people know how to use them. I think they're a powerful tool, and of course, right now there's FAA regulation of that, and that becomes another issue. But nonetheless, when you consider if there's a shark sighting, and you have to launch a jet ski to go out and confirm that, or you could fly a drone from headquarters or out of the back of a truck, that's a far more effective way. And if we can provide better tools to give them more information when they sight the shark, that's even better. So I think a lot of lifeguard agencies would like to adopt them more. It's just right now I know a few.
Are there any colors or patterns on your swimsuit or wetsuit that you can wear?
That's a common question. Okay, so as best we know, most sharks are colorblind. They cannot see in color. So this whole yum yum yellow thing probably isn't true. There have been arguments about, wetsuit patterns that might break up the pattern so you don't look like a seal, putting eyes on the front, so it looks like that predator or the prey knows the shark's coming. There's no good scientific evidence that any of those things work. My favorite one is the one from Australia that has the bands. It looks like a zebra. Okay, that one is just bad science, and I'll tell you why. So the argument is by having banding, there are sea kraits, right? There are sea snakes that are poisonous. And the thought was sharks wouldn't eat sea snakes because they're poisonous. So people invented wetsuits with these big black and white bands, right? And their thought was it'll look like a giant sea snake and the sharks will avoid them. This is the ridiculous part. Guess what the number one favorite thing of tiger sharks is in Australia? Like stomachs are filled with hundreds of sea snakes. So imagine you're wearing this giant sea snake outfit, and a tiger shark swims over and goes, wow, awesome. So the problem with a lot of these things is there quite often isn't good science to back it up. Now, I'm not saying it doesn't work. What I'm saying is there's no good evidence that it does. when it comes to shark repellents like electrical devices, chemical devices, magnetic devices, there's been some science done, and the science that's been done is ambiguous. Some sharks respond, some sharks don't. Some sharks respond in the presence of bait, some sharks don't. So my philosophy, because we tested shark repellents in the shark lab for 20 years, I never saw one that I would bet my life on. The bottom line is, and what scares me the most, is people can buy these, and if they make you feel better, sure, they may work. We won't really know. The manufacturers can sell a lot of product before somebody gets bitten wearing one and turns around and sues them. And the reality of it is, if your chances of being bitten are already like winning the Powerball, what's the point? So if it's a matter of making you feel better and you have the money to do it, buy it. What I'm telling you from a scientific standpoint, there's no good evidence that it works.
When you say it's safer to swim in groups, what's that based on, that sharks are afraid of groups of people, or your individual odds are a little lower when you're
That's right. Can you swim faster than your friend? Yes. No, it's based on just the statistics. So, for example, really popular beaches. Those are the best places to surf, best places to swim, because it is really rare to have shark bites. At least, and again, I have to qualify this, because in places like Florida, really popular beaches, kids get bit on the foot a lot, right? Those are reef sharks. Those are small reef sharks. They're kind of hit and runs. They'll kind of bite them in the foot or they'll bite them in the hand. The thought is, and those are crowded beaches too, the sharks are migrating through, the water's kind of murky, there's a lot of bait around, there are a lot of people in the water. The idea of the white of the sole of the foot flashes or the hand flashes, the shark sees it, kind of thinks it's bait, rushes in, takes a bite, takes off. That's very different from a tiger shark bite or a white shark bite or a bull shark bite. So in those cases, what we know is you just don't see those at popular beaches. So Waikiki, Huntington Beach, all those beaches, lots of people in the water. My belief is that, at least for the larger individuals, they avoid those places. We're stinky, we're smelly, we're loud, and we chase away all the big things that they want to eat. So I would argue, go to a popular beach. Statistics say you'll be safer, unless you get knocked over by some other person, or people are more dangerous than sharks.
Is there any way that CN committee that's here, since we're such a rural, renowned surf community, is there any way that we can create a coalition to help you in support of your grant writing? To put the grants ahead of
Love
time
that.
a little bit to help our community be safer?
Sure. I
All
mean,
ages in the water.
right.
They're in the water at dawn.
Right.
Parents are picking them up and taking them to school.
Right.
Then you got some of us that are a little older. We like to hit the mid-morning session.
Right.
Sando's filled all day. Trestles is filled all day.
Yep.
This is a world-renowned
Yep.
surf community.
So one of the,
We do to help you.
sure. So one of the things that would help, and one of the things we're working on developing now, is a kind of a citizen science project. So one of the things we want to have is a website where people can report sightings of sharks. So we're working on the database now, and we're working on a little bit of education information, because we want to give what we need to use that science are accurate accounts, right? So to do that, people need a little training, right? So we'll have a page to tell you how to identify a leopard shark from a soup fin. Or if a baby white shark swam by, how could you tell that from any other shark? So our goal is, once we get all that done, you would have fields that you could fill in. And what we really need would be accurate information about where you were surfing or swimming or diving, the time of day, and your best guesstimate of identification. The other great thing is, now everybody has a cell phone, they've got GoPros. We can link any video footage or still footage, and that gives us the ability to go in and say, okay, you called it this. We looked at the footage and we think it's this. So now we can calibrate some of that, and we have a permanent record. So this is something that we want to start to use and employ. Hopefully in the next year, we'll have that website up. And that's where actually everybody can help, because we'll have better data. Of course, the other part is just money. So the federal government doesn't fund this kind of research, because frankly, if you don't eat it, they don't care about it. If it's not endangered, they don't fund it. Same with the state. So private funding, so Monterey Bay Aquarium's put more money into white shark research than any country. They've invested $2 million in white shark research. Most of what we know about white sharks in all of California was through funding from Monterey Bay Aquarium. But it's hard to find funding sources like that because this technology is not cheap, but it can answer questions we can't answer any other way.
And what you got done sharing with us is that there's all kinds of demographics going into
Oh, absolutely.
water tabs,
Yep.
visibility, all the things you shared.
And if we didn't have any of this technology, I wouldn't have been able to tell you any of that. So imagine what I'll be able to tell you in 5 years.
How scary should be the kids in the room to be, for instance, if you, as a parent, say when you cross the street, look left and right so you won't get run over. So as a parent, what should we tell them when they go into the water?
So that's a really good question. And you know, the hard part is we're still learning, so we don't have hard answers. My philosophy is the more we know about basic biology, basic behavior, the more information we give the public can make better decisions on how they use the ocean. Moms can give their kids better information about how they use the ocean. I think the most important part that we need to start thinking about are there predators out there that live there and they're doing their job. We never had to worry about them before, but we now have to think about how we can share the ocean with them. Now, I'll give you some examples. People will send me pictures of a family that came from maybe Kansas. A seal comes up on the beach, has domoic acid poisoning, so it's already kind of, disoriented. They'll place their child next to the seal and take a picture of them. Now, at what point did we become so predator illiterate that we would think it would be safe to put our kid next to a wild animal? Right? In Yellowstone, same thing. People have their kids hand feed bears on the side of the road. That's nuts, right? So the bottom line is this is about education. This is about reminding people that there are predators there. If you see a shark, it doesn't necessarily mean it's going to bite you. It's kind of a cool thing, but there are things that we have to start remembering when we go in the water. So if you see a shark, that's actually a cool experience. Keep your eyes on the shark. If the shark comes back, always keep your eyes on the shark. Try to back your way out of the water. Most cases, trust me, how many people go in the water regularly? I can guarantee you white sharks have swam underneath you and you did not know it. I'm not trying to freak you out. I'm just telling you something that's probably happened over and over and over again and nothing bad happened. The only reassurance I can give you is that statistic.
Hear about commercial operators that jump the water to attract sharks, see them or in the water with them, and then that acclimates sharks to humans. Is there any truth to that? Is that regulated?
So
Does it happen very much?
it does, but just not here in California. It just doesn't happen here. In other places like Florida and many tropical places, they'll do that with reef sharks. They'll do it in Hawaii. There's been a lot of research done looking at that. Sharks are actually pretty smart animals. They recognize free meals when they get them. They'll come back reliably. By and large, when you consider how many people go on those shark diving events, how few accidents that occur, I think once again kind of illustrates the fact that every time you see a shark, it's not going to bite you. So right now in California, that doesn't happen.
There are a few commercial operators that do that.
There were some that were working up around the Farallones, but all those operators, because that's inside the sanctuaries ban that. So there's no place in California. Guadalupe, they do that. Some other places, but not in California. At least that's legal.
How about paddle boarding? Are sharks curious by paddle boards? Are you safer on a paddle?
Yeah, so the coolest footage that I ever get are from San Clemente people, right? Or Sano people, stand-up SUP people. Because they're out there, they've got their GoPros with them, and everybody knows off Sano, and for whatever reason, it's like that's where the toddlers hang out. I call them toddlers because they're between 7 and 8 feet long. They're toddler white sharks, but they seem to be curious of the boards, so they'll kind of come up close to the board. And I've heard stories of people saying, "Oh, the shark bit my board." And when we look at the boards, we see no marks. So what happens is the sharks are curious. If you're just kind of standing there, you're hanging out, the sharks will come close, and if you move, you startle them. If they're so close, when they turn to move away, their tail hits the board. So as best we know, and based on the footage, there's no evidence that that shark that hit the board has turned around and come back. I've never heard of that before, because that would be potentially a sign of aggression. So I equate a lot of that sort of approaching and then kind of, what is that? Oh, and then it moves, and then they get scared and they take off. So far, those are the only reports that I've heard of. And, surfers see the same thing in Santa Monica. They see the same thing off Huntington Beach. And it's not just the stand-ups, it's the regular surfers. We'll see them sometimes. They'll actually start dropping into a wave, and they'll see a white shark right in the wave, and they'll veer away from hitting them. And sometimes they'll say, oh, I'm pretty sure I hit it. I fell in the water, I was freaked out, and the shark, of course, is like out of there. It's like, I don't know what just hit me, but.
So do these toddlers need to be feared?
They're more curious. So the rule of thumb with sharks is this. It's about size, right? It's like anything else. So once they get over a certain size, they become a little bit more confident, right? So once they're 8 to 10 feet, I've heard that they will more likely approach a board than a 5-footer, than a pup. So they do become a bit more confident at that point, but everybody that I've ever talked to, especially the Sano crowd, says if they splash, if they whack at them with a paddle, they'll just take off. So that's all I can really tell you. We've learned a lot about the babies. We've learned a lot about the adults. And everything in between, we know virtually nothing about.
Do you think the water coming out of songs has like kind of enhanced the nursery effect here in San Clemente? Because between Dog Patch
Right.
and Trail 1, it is like shark fest.
So, there's been a lot of hypothesis about that. Unfortunately, we have no data. So now that Ryan's receiver array is down, we're not that far down. It would be great to do some tagging, put some receivers out there, get some good temperature data to see. In certain locations, the young white sharks are very temperature sensitive. They like warm conditions, and they are attracted to warm conditions. So, in places where the water may be warmed artificially, it's possible that provides a refuge habitat for them. But we have no good hard evidence that that's the case. And again, how do we explain Huntington Beach, or how do we explain Santa Monica? They don't have a nuclear power plant discharging there either. So those hotspots, the behavior of the sharks around those hotspots seem no different than what we see at Huntington Beach or Santa Monica Bay.
You mentioned by the time a shark reaches adulthood, they spend a bulk of their life out in the ocean, to and from Hawaii and out further west. Is there any specific time of the year or month in general that those adult white sharks are going up in population or coming in?
So based on the satellite tagging data, that starts in September. So around late August, September is when they start migrating back into shore. We've had some that there's evidence that they'll come into Southern California in the spring, so those probably are the females. But most of the satellite data shows them around the offshore islands, not along the coast. Now again, remember the technology we're using requires them to come to the surface to get a good detection. So, and most of the white sharks that have been tagged at the Farallones in Guadalupe have pop-off satellite tags on them, not these. So, unfortunately, remember, the positional accuracy of this thing is like 60 miles. So it could be at Catalina, or it could be San Nicolas, or it could be at San Clemente. We just can't really tell. So until we get better, more acoustic transmitters on those, we won't be able to answer some of those questions fully.
I just have another question. I know you talked a lot about shark movement and stuff, but what about, have you done any research? You mentioned a little bit about stomach contents. Like, are you finding in shark stomachs, like, I know we have a marine debris problem, so is there plastics or any kind of human type debris in them? And then also, what about tissue? Is there any sort of tissue analysis on foods and such?
Yeah, so I didn't talk about that because this would be a 2-hour talk. So the answer to your question is yes to everything. So every shark stomach I've ever dissected, there's some plastic in it, whether it be small pieces, large pieces. I mean, they're scavengers. They're really good scavengers, so they're going to pick those things up. When it comes to contaminants, that's part of the story I didn't talk about. The baby white sharks that we've tested have had some of the highest contaminant loads measured in any shark. So normally contaminants like PCBs and DDT get acquired over an animal's lifetime and build up slowly over time. So we couldn't figure out how a baby white shark would have some of the highest levels measured in any shark. Then we began to figure out that sharks are very much like mammals. So during pregnancy, and white shark pregnancy lasts about 12 months, the mom white sharks, which by the way eat marine mammals, which have big fat blubber layers, is where all those contaminants collect. And those moms have been eating those big fat marine mammals for decades, right? What they're doing is they're passing on those contaminants to their young during their pregnancy, so that those babies are born with high contaminant loads. So the thing is we haven't seen any ill effects of that. We can't say for sure, but some of the sharks that we examined that had really high contaminant loads looked just as healthy as one that had really low contaminant loads. So my assessment would be, remember, some of those contaminants like PCBs and DDT are going down in our environment because we've done a better job at regulating that. So 40 years ago, it was probably far worse than it is now. So it could be that was another impact on the white shark population.
Are you involved with Keith Bowe's Mako shark tagging up in LA?
Yeah, I know Keith pretty well. He's a great fisherman and eager to help. He's worked with us before and helped us get tags out. Yeah. Nobody knows shark fishing better than Keith.
Sure. I work for the city of St. Helena. Sometimes I work out at the pier, and sometimes when I come to work, there's signs on the beach that say shark signs, no swim, and the whole community does not, because surfers can't go surfing and the tourists can't go in the water.
Right.
And they just took the train out from San Bernardino, and you can't go in there. So are those signs up for a certain time frame before, or how does that work?
So, one of the great things is a couple years ago, all the lifeguards from San Diego to Santa Barbara got together and put together protocols so they all could work in unison. They were all following the same protocols based on shark sightings and when sharks make contact with a board or a person, things like that. Everybody follows the same protocols and everybody communicates, which is really good. The tricky part is it's really hard to assess whether a shark is being aggressive. In fact, in most cases, a shark sighted, there's no good way to assess whether that shark is going to be aggressive or not. However, as a safety protocol, a precautionary measure, the simplest thing you do is post signs and pull people out of the water. Now, what our goal is, based on the data that we find on shark behavior, is to give the lifeguards better information so they can begin to change those protocols to better suit the needs. But it has to be based on good science, right? Right now, what you do is use safety protocols to try to reduce the chances of something happening. In my opinion, the greatest value of posting signs is it reminds people of the fact that there are predators in our coastal ocean, and they have to be aware of that when they go in the ocean. So whether it be kids surfing, playing in the surf, visitors coming here, I always tell people, be ocean smart. It's more people are killed in riptides, but we have much better education for riptides than we do anything else. So all of these are things that people need to be aware of when they go to the beach. Stingrays, jellyfish, pollution. So just putting sharks in a separate group I don't think is a good idea. We need to group all ocean things together, and we need to make more people ocean smart.
What is the size when people are pulled out currently?
It's over 8 feet. And of course, there are very few sharks in Southern California that are over 8 feet that don't fall into that white shark category or some large predatory shark like a mako or something like that.
So you had said that sharks don't like popular beaches with lots of people, lots of activities. There's some kind of, so you have a situation like that, a shark is sighted, you get everybody out of the water, it's happy. Is there some kind of hazing technique you can use to go away?
So actually, and again, I think a lot has to do with the size of the shark. So for example, the little ones, the babies, the 5-footers tend to completely ignore people. And we had the lifeguards using the jet skis to try to drive them offshore so we could actually fish for them. They won't do it. You get them 50 feet offshore and they turn around and cut back. They want to be in close to shore. The bigger sharks, as best we can tell, and again, we don't have a lot of data on those tweeners, the kind of the teenagers. But the data that we do have suggests they do not stay. pass through. And that's another reason why lifeguards may close a beach. They'll communicate to neighboring beaches, but the best available data that we have for the larger sharks is 3 hours later, that shark could be 20 miles away. And the babies, even the 7 or 8 footers that we've tagged, that we've been able to track, we had one that was checked in at Sunset Beach, 5 hours later was in Santa Monica. So the problem is you close the beach for a week thinking, oh, that shark's going to hang out. There's no good evidence that that's the case. In fact, the only evidence we have is that shark could be 20 miles away 3 hours later. Now, of course, that depends if you have a dead whale on your beach, right? Because that might be something to keep animals around, but all the other science evidence that we have suggests kind of the opposite. But I had a question right over here first. Yeah, question. What do you do if you see one? Well, for me, I'm like, woo. I think the key is if you can see it, that's already a good sign, right? So keep your eyes on the shark, watch it. A lot of times they'll just kind of cruise by you, they'll look at you, and then they'll just keep going. If the shark turns around and comes back and checks you out, just kind of moving nice and slow and keeps going, just keep your eyes on it, watch it, because it knows you're watching, it knows the gig is up, right? Now if the shark starts coming closer and faster, you just back away, keep paddling back to shore, keep your eyes on the shark, look, keep your eyes on the shark, keep backing away. That's all you gotta do.
Quick related thing, it made me really feel good for confirm my theory, and that is because the sharks have been super bad this last year. If you can see them, my theory is that's a good thing in the sense that I remember seeing they feed from blind side coming straight up, the big ones, and they've been super docile to the 6-7 footers, and they're just but they swim around me.
Yeah.
I'm curious looking at it.
Yeah.
So is that a good thing? Please tell me.
Well, so far as best we know, it's not a bad thing, right? So, again, I think a lot of it is curiosity. Remember, these shark, an 8-foot shark is a toddler. That's a toddler white shark. So from a kid's perspective, they're learning, right? So they're kind of learning what's around them, what's a threat, those sorts of things. So all I can tell you is based on statistics, I can guarantee anybody that's spent a lot of time in the water, that has happened. You didn't see it. Nothing happened. Does that help? Feel better? Okay. So, and again, you're looking at a community right here. Multiply that by 10,000. That's how many people are using Southern California waters every single day. There are very few places in the country where people can use the water every day of the year. When you think about that, how many people do that? And there are people that religiously do that. I mean, the number of people bitten by, it's like winning the Powerball. It's that kind of probability. It's ridiculously low.
What size shark would be eating the sea lions?
Okay, so that comes back to white sharks don't know they're white sharks until they're usually over 9 or 10 feet. And that's when they make the transition. So their teeth start to change shape when they get about that size, and that's about the size when they start taking cracks at marine mammals. So their teeth become broader, they become more serrated, and the bottom teeth become broader and more serrated. So when they're babies, their teeth actually look more like maker shark teeth. They're clearly designed for eating fish. They're not designed for cutting hides. They're not very good at that. So it's when they get to be about 9 or 10 feet long is when they start making that transition. So, but they're horrible at it. I mean, people have seen them try and take cracks at healthy sea lions. They can't even go close to them. So it's really got to be a sick or weak animal that they're going to be able to actually take. And quite often they scavenge. So when you think about how many sea lions we have around here, and a lot of them are starving to death because of the El Nino, that's a lot of just floating dead free meals for those sharks.
See any evidence backing up the size and dominance of sharks and their depth in the water column and how they're seeing humans on the surface as a more dominant predator, et cetera, et cetera?
So
And
again,
other sharks, obviously.
right. So we have to separate out the babies, right?
Sure.
So because mostly what we have here are babies. Those things are scared of people. Sure. They'll move away. There doesn't seem to be any dominance there. And like people were mentioning, the 7 or 8 footers are a little more curious. They'll come a little closer. That's the best we see from that age group, you know, the kind of babies through toddlers. The larger ones, again, we don't have a lot of data because there aren't very many places where there are a lot of people in the water where you have those large sharks where you can observe both.
Do you think that breaching is gonna have an effect on population of sharks?
In tropical waters, yeah, sure, because the coral is the basis of the food chain, right? So to a certain,
Migration as well?
absolutely, because if the coral reefs start to die, as a result, there's going to be less animals being able to feed on the coral. That means they're going to leave, and then there's not going to be anything for the sharks to eat, so they're going to move. So, yeah. Everybody's had enough of sharks. Thank you.
Thank you, guys.